Hello, and welcome to section 4.3, differentiating the natural logarithm function. Guess what? Just one new rule, and that's this one. The derivative of the natural log of x is 1 over x, and I will give this on the next exam. This rule can be used with the product and quotient rules, with the chain rule, and with implicit differentiation. So we've got lots of examples below and in the text. We can also revisit finding equations of tangent lines where the derivative gives us the slope. And potentially we could revisit finding max-mins, though solving f prime of x equals 0 is more difficult, so we actually aren't going to do that here. All right, example number 2, given f of x equals the natural log of 5x squared plus 3x, find the derivative. So immediately what I see, because that inside stuff is fancier than just an x, we're going to need the chain rule. And so the way that looks for a natural log, if it's the natural log of something fancy, which we denote with a u, we're going to immediately go 1 over that fancy stuff, 1 over the u, and then the chain rule says we multiply by that extra derivative of that inside fancy stuff. Just like earlier, but now it's in the context of a log. So using that for this function, I'm going to give it a label, f prime of x. First thing I do is write 1 over that inside stuff without changing it. 1 over 5x squared plus 3x. Then the chain rule says I have to multiply by the derivative of that 5x squared plus 3x. And you could go right to the derivative there. I always like to say what I'm going to do first in my notes. So that's going to be 1 over 5x squared plus 3x times, let's see, 2 terms, each of them have an x. Let's see what we get. The 2 comes down, times the 5, we get 10x plus 3. And we're pretty much done. To tidy this up, I might just go ahead and write it as a single fraction. So f prime of x equals 10x plus 3 all over 5x squared plus 3x. You might notice we could factor out an x on the bottom, but we don't get to reduce the fraction at all, so it would be your option if you wanted to factor that out or not. And if you do put that into the computer, you would need to put it in with parentheses around the top, parentheses around the bottom. Probably already getting the hang of that with the quotient rule. Let's do another example. So example number 6, given f of x equals 4x times the natural log of x, find the derivative. All right, we've got 2 pieces that are being multiplied. Each of them have an x in it, the 4x, times the log x. We have to use the product rule. And that's the same as always. If you've got the product of 2 things, each of them with an x, then we take the derivatives but keep them separate. U prime v plus u times v prime. So here we go again, because just getting used to the stuff with logs. I'm going to take the derivative of f prime of x equals. I'm going to take the derivative of the 4x and leave the natural log of x alone. And then my plus sign, I leave the 4x alone, and then I'm going to multiply by the derivative of the log x. And that's just a plain old x inside, so no chain rule on this one. So let's see here, from the derivative of 4x, I get a 4 times the log x. And then this is interesting what happens. We have 4x, and then times the derivative of natural log of x is just 1 over x. And look at that, we've got x's that cancel. So we could write f prime of x equals 4 times the natural log of x plus just a 4. And if you wanted to factor out the 4, nothing wrong with that. 4 times natural log of x plus 1 would be an alternate way to write that. I'm okay with either way. So there we go, 2 times of a derivative, not too bad, I hope. Chain rule, definitely super important to get. Let's just keep going. Now the next 2 examples are really important to notice the notation. It can be a little tricky about whether there's an exponent inside the log or outside the log. So I'm going to scroll up. Let's see here. Well, actually, so I'm sorry, just one more example. So given f of r equals 5. Now notice the brackets and the sixth power outside the brackets. So this is an entire log function, the log of 2r minus 1. All of the log there is to the sixth power. So not the same, because this comes up in your homework, so I'm mentioning it. So it's not the same as 5 and then natural log and then parentheses this way, 2r minus 1 with the sixth power on the parentheses of the log. That 6 is inside the log, inside the ln, whereas this 6, because of those extra brackets, is outside the ln. And that's important for the chain rule. We need to sort of know the layers of how this is built up. So here we go. The f prime of r, just use the notation that we're given. Now this 5 in front is just going to be tagging along. And so then the 6 that's on the outside of everything, the 6 comes down and multiplies it. And then we've got natural log of the 2r minus 1. I'm going to switch to round parentheses because I can emphasize it a bit more, to the fifth power, right? So there's that outside power happening, the 6 coming down, leaving a 5 behind. Now we got to tackle that chain rule. So we're going to multiply by the derivative of all of that, the natural log of 2r minus 1. All of that stuff is in there. So chain rule is going to happen a second time. So now we have a 30 in front times natural log of 2r minus 1 to the fifth power. And then when we take the log of the derivative of log of 2r minus 1, first thing we have to do is 1 over the 2r minus 1. And then because that's not just an r, it's a 2r minus 1, we're going to do another chain rule and take the derivative of the 2r minus 1. And again, if you want to just go right to derivatives there, that's fine. But just to make it clear why we're doing each step, I'll write out a few more steps in my own notes. This first part is all done, so we just keep copying it down. 30 times that whole log 2r minus 1 to the fifth power times 1 over 2r minus 1, and then times a final 2. And there's really not a whole lot to do with this. We could put it together into a single fraction. So maybe for a final answer, f prime of r equals, on top of our fraction, 60 times this natural log of 2r minus 1, all to the fifth power, and all of that over another copy of 2r minus 1. We're not able to reduce those 2r minus 1s because that 2r minus 1 is really wrapped up. It's inside of a log, and it's inside of a power. So that is definitely not free to be reduced. And not even the 2 in front, we can't, because that's part of the 2r minus 1 stuff. So that's about all we can do with that particular problem. I hope that makes sense. The next problem, as you can see at the bottom of the screen, is implicit differentiation. And it's a pretty big problem. It goes up several notches at once. So I'm going to go ahead and leave now and come back in part 2. See you there.